Okay, can you see it?
Yes.
Right. So I think it's better to just go to the directory. So what we have in here, first of all, the pull request includes two parts. First one is everything around the behavioral model. So the older P4 files are moved to the subdirectory, but besides them, we have all of the tools and scripts to be able to compile them and use them. So there is a description in here how to use that. We have to do a one-time action to actually prepare the environment. So this will provide us with a Docker image that has all the P4 compilation tool chain, which is based on P4.16. It will allow us to compile the P4 behavioral model. Next, we can do the compilation itself. Right now, it is based on the BMV2, the one that also provides the simulator. So here are the steps to build it. Pretty straightforward. And last pieces are the running the simulation. So to run the software switch, there is a single command. Plus, you can load a configuration using this, and it will launch a CLI connected to that software switch. It is in the form of the P4 runtime CLI. So this is what we talked about. What is missing is a translation from SAI to P4. So this directory has all the tools related to P4. Then next one is SAI. So here, instead of having the headers themselves uploaded, that's what we were talking about last time. Instead of having the headers, we can have otherwise an agreed upon tool that can generate those headers itself. So it's also a single script with an accompanying template to make it easier to generate this code. So what it does is basically I posted a help file in here. So to use it, you just run this tool. You provide a path to the behavioral model. You give your API a name, like in our case, it will be dash. So here it is, path to the BMV2 JSON file. And if you remember from what I was talking in this directory before, to get this file, you need to build our P4 model. So that you build it, you have the input to the API generation tool. Now you can generate the API, provide a path to that JSON file from the compilation, give it some name like dash, and some additional options like you can print some debug information. You can provide a SAI GitHub URL. By default, it's using the Azure SAI. A possible list of tables to ignore from the P4. Like, for example, if we have something that is actually mapped to underlay, for example, like some global variables, you don't really need APIs for them because you already have them. You can ignore those. One of them would be appliance table. And optional branch, again, default is master, but I saw Goan created a dash branch inside, so you can use that. So this is the tool to generate SAI APIs.
So Marian, just a quick question. In the overlay folder, the APIs are created using this tool itself? They
were created using this tool, but now the process is even a little bit more complete because you saw those APIs were kind of separate from the rest of SCI APIs. Now I improved the tool a little bit so that when you actually use it, you will it will clone a SCI repository and integrate the APIs into that. So you get SCI that you
That's
can
nice.
actually compile in one folder.
I was hoping you'd come up with something like this. It's really good. I have another question. Is there a way to specify, besides a branch, some other way of specifying a commit number, just in case someone wants to read something at some stage in the future?
Yeah, we can definitely add that. It's pretty simple. It's just a Python script. So if you need more options, it's like 5 minutes for me to add. So maybe just leave some comment. So there, yeah, by the way, the pull request itself.
That's nice. Really nice work.
It is number 32. Yes, so I'll just post it in the chat.
And I'll put it in the meeting notes too, Marian. Thank you.
Where is it?
So how would we fit this, let's say in the long-term scheme of things, how would we fit this into some kind of a workflow, I'm wondering? I can imagine going through step by step and reading this and exercising the steps manually, but how would this become sort of a fully automated system? You know, how would this fit in, do you think? Is that future work?
For testing or for building Sonic image?
Either, just, you know, a production pipeline of some sort. Like, have you thought that far ahead, or is this sort of a work in progress?
Yeah, so for now I was trying to add everything into the to contain everything in the Docker image, so it can be used from there, the simulation as well. Hold on, my Teams crashed. So right now it is in the Docker container. So I don't know what is the environment for testing. So if it is Docker as well, we can probably merge those two together. So I don't have the full picture yet. What I'm missing is what is the environment for testing itself.
Yeah,
and yeah.
Even before we start testing data plane, for example, one thing we could put on the table would be have a GitHub action, automation pipeline. So when you commit P4 code, it runs an entire tool chain on it, right? Just to verify that.
Yeah.
That would be a minimal kind of a test to verify the tool integrity. It's just a suggestion. I'm not saying that that's urgent or anything, but that would be one possible outcome.
Yeah, I agree. It's possible, of course, to verify that SCI API is generated properly. SCI itself has scripts for verification, so definitely possible to run these.
Okay. Yeah, like anytime anything's checked into the serious pipeline directory, that would be a trigger, for example, so that it just makes sure the whole thing is still intact. Some basic test, you know, some script that says, yeah, all these files came out of it, something like that. If you want to talk about it offline sometime, I'd be happy to also.
Mm-hmm.
Yeah, I think I like this idea is in the sense that, you know, the SCI API folder, no one should basically manually submit any files there. They all basically be auto-generated through the tool, so as to know that, okay, this is not something manually modified.
Yeah, and something that utilizes all this will need to be cognizant of the version of the SCI repository from OCP that it's referencing, and the version of the serious code, etc., to produce some kind of intact configuration, right? But to figure all this out over time, but what's the final configuration consist of, right? It should all be traceable to versions of things. That's longer term. This is good work.
Great. So Silvano or and Gohan, anyone have feedback here, or we want to just go ahead with the pull request?
Yeah, this is Mario. I have a couple of questions, Marian. So the simulator is simulating both the P4 part that describes the overlay and the underlay? Like, is the underlay like hardwired in the simulator? How does that work? Because for the overlay, there is the P4 description. For the underlay, not.
Right, we don't have underlay yet included because it is not described in P4.
Oh,
Do you need some
okay,
help
so
with that?
the simulator.
Go ahead, Mario.
No, just to make sure I understood. So the simulator is currently simulating only the overlay part.
Well, there is some portion of the underlay as well because underlay is not really that huge at the moment. So what we just need to do is to have a few global definitions per appliance, like what is the appliance virtual IP, what is its MAC address, and so on. So if and we have a dedicated table to get those parameters. So this is what it does right now, but probably it might be missing some things in the future. Yeah, so for now it's quite straightforward. We just fill a bunch of global variables per appliance, and that's it.
So basically, by filling out those global variables, you sort of emulate the underlay or part of the underlay. And in general, and here I think is what Christina was asking before. How do you see this evolving? I mean, would you expect that we maybe with help from the rest of the group develop some sort of hardwired underlay behavior, or do you expect to write the underlay behavior also in P4, although it's not, it's not part of the site specification, but just for the sake of being able to execute a full emulation and then emulate it on the behavioral model? Do you have? I mean, do you have a plan? Do you have a vision?
Yeah. So I think this is even a little bit broader question. So I have this is point number 2 that I wanted to go into. Here in the pipeline directory, there is a to-do list. What's still missing from the pipeline? And short answer will be that yes, we want everything to be part of the P4 model, and so that everything will be emulated. For that, we are missing a few things. Probably, well, underlay, I would say, is one of them, but I don't think it's the highest priority. There is also connection tracking, which is not yet supported by BMV2, but we are looking into that. There is also, yeah.
Had you taken a look at the connection tracking posted by, I think it was Excite?
Yeah, I saw that, but oh, hold on, maybe not that one. You're talking about the PNA version?
Yeah, it was posted by Mario, I think.
Mario, okay. I was just curious if you had seen it.
Yeah, I've seen that, but I believe it has the same problem. There is no simulation available for it.
Thank you. Sorry, I didn't mean to interrupt you. You were in the list match types.
Yeah. So also, regardless of like what target architecture it is, another problem is that we need some more advanced match types. Like we have ternary list and range list. And also because of those two, we don't have ACL stages actually working, because right now the pipeline is on the packet basis, not on the per flow basis, because of connection tracking missing. And those mesh types used by ACL. So I believe this is the higher priority, to have at least the overlay complete. And probably, yeah, I would need any help possible. And then we can get to the to the modeling of the underlay, but as they are quite nicely divided, I believe it's like a little bit lower priority.
Yeah, so the question I have is,
guys, 1 second. Andy's had his hand up for a while. Andy Fingerhut.
Thanks. So let's see. I guess first question. So the simulation to do here, this seems to match exactly the list of things that don't have published open specifications that you've extended in the P4 program you've written. So that's still to do, providing implementation of how to an open source packet processing switch, software switch that implements these features is still to do.
I'm not sure I understand your question. Can you please try to?
If I follow your instructions, can I send packets into a virtual Ethernet interface to BMV2 and it will run your P4 program with a list or list range match type, and will it do connection tracking state updates?
Oh, no. Yeah, so that's what I'm saying. Those two are missing from the simulation itself.
Okay. So those are exactly the things that PMA doesn't have either, and so we and do you have an expected timeline for when you think, are you planning to release those changes?
I think he was asking for help. Were you, Marian?
Yeah, I didn't really think about the timeline itself. So we have some work done already on the stateful tables and connection tracking, but it's not fully complete. So we could share this and see how we can integrate it. But yeah, I don't have the timeline because I didn't think about it.
Silvano, did you have something?
Yeah, and sorry for my ignorance here, but I'm trying to understand how the SCI API get integrated into the BMV2 simulation. So what do I run at the end?
That's a good question. So there is another piece missing. Let me write it down. It's SCI API implementation for BMV2. This is also missing, but I believe it can be integrated as part of the SCI API generation tool. So since we can generate SCI API, implementation based on the BMV2 interface can be also auto-generated. It's just not yet done.
I'd like to show a picture right now because this is relevant. I've been working on a diagram to show the P4 simulation options, and it might help inform this part of the conversation. Is that okay if I share for a moment?
Marian, is that fine?
Yeah, Chris, go ahead.
Okay.
Thanks. And then we can bounce back.
Okay.
Let me know if you can see this.
I can see.
So I think what we're talking about is this part of the diagram. After our last meeting, I realized that the diagram was confusing to people, so we tried to split it up into different sections, and we'll cover more of this at the end of this meeting, hopefully, but this part's relevant. What we're talking about right now is this, I believe, Marianne. You have this BMV2, I call it BMV2 Plus, in a V1 Plus architecture, and you're using P4 runtime to configure it.
Right now,
we're striving for this, right? This is a goal, right? Something like this.
That is correct. This is the goal. It's not yet implemented.
And is that the correct interpretation? What I heard, I think, when maybe Maddie was describing how it would work. Is it going to be something like this, where you'll actually have an adapter to the native P4 runtime and it'll get serialized? Okay, great.
So essentially, what Marian basically said, the SCI implementation for BMV2 is that the SCI adapter, which essentially is going to make the P4RT call to the BMV2. And if that is the case, can that be automated? Can this be auto-generated?
As I said, yeah.
Okay.
Yeah, but I think Silvano's question was a little bit different, or if not, I have a different question, which is, how about the SCI, the actual SCI, existing SCI API, the one not the dash psi. How does that get integrated in the BMV2? Because the dash psi, I understand, it maps directly on a P4 runtime related to those tables described in the behavioral model.
Let me add to Mario. Let me add to Mario 1 second. You see, for the overlay, I understand. You have a P4 model, you generate the API, and you generate the mapping. It's fine. I have no issue. You know, I understand that flow. For the underlay, the API already exists. So the model cannot generate the API, but it needs to generate the mapping, which to me seems to be a different process.
But Silvano, you know, one thing is the objective of this one. If we stay on this objective, is to really test the dash psi API, right? So underlay APIs are essentially the older API that currently already exist as part of Sonic, and then, you know, they get tested and so forth. So if the objective is to test the dash API, then this suffices it. But if you want to actually, you know, expand the objective, yes, then you need to really bring everything else together in there and so forth, right?
My understanding was that Gerald has been very, very clear from day one. He wants to test underlay and overlay.
Gerald?
Especially because I would assume that the overlay is relying on the services of the underlay. So if you want to test it, you need to configure and run the underlay as well.
I mean, don't take me
Yes,
wrong.
overall,
Okay.
in totality, yes, you know, you do need to test everything together as one thing. But that testing is a different objective versus just the testing of the dash psi APIs, which is just to say that, okay, if you are going to really give an input as, you know, which is an output of an underlay and input of the overlay, and then you just basically egressing out of the overlay up until that point, if that's the only testing that you need to do, then this suffices it. But if you want to expand the objective to really have both end-to-end testing of underlay and overlay together, then that's a different objective, isn't it?
No, I don't see the intermediate step. Sorry. Either you do what Marian is doing right now, you hard code the underlay with some table. That's perfectly fine. And you test only the overlay. Or you go to the full-blown testing of the underlay. I don't see an intermediate step.
But why it is or and not in addition to? Why it cannot be set of tests that test overlay only, and then there are set of tests that test end-to-end overlay and underlay?
I agree with that. I have no issue with that. I have no issue.
That's exactly what I'm saying.
My point is the model to generate the mapping from the underlay is different from a model to generate the mapping for the overlay. Because in the overlay, you generate the API and the mapping together, so they are consistent. In the underlay, you have a model, and then you have an API, and the two things are already defined.
Right.
And then you need to generate the mapping. So the mapping is different. Or the tool that generates the mapping is different.
I agree. In the underlay, there is no really mapping. It's nothing there is auto-generated. It is well-defined. Like, just a minute. Let's put things in proportion. The underlay of Dash is fairly simple. Fairly simple. Like, it's only a router. Nothing there. Nothing else is there. At least for now. So I believe
I think there are multiple interfaces. There are interface up, interface down. There are all the events that we need to do a testing.
I'm not sure. Just a minute. I'm not sure. Again, between the full-blown testing, like a full-blown system that mimic a real harbor, to a tool that will help us test scenarios, I believe that in this, like between those, there is a lot of room of. It's not like all or nothing. For me, what is the most important thing is to get the behavioral model, meaning that the packet in, packet out, like bringing down interface in the middle and creating some kind of an exception. It will happen afterwards. What I would like to have, a test suite that I can inject a packet, and then I will have a golden model that describe how the packet should go out. And for that, the underlay is fairly simple.
So does that answer your question, Solano?
Yeah, Yeah, it answered my question, but
Okay.
the issue, Christina, is we need to be very clear in this project what we are trying to achieve. If what we are trying to achieve is what Mariam says, I'm fine with it. If what we are trying to achieve is a full testing, I am not fine with it. I can go both ways. It's not a problem for me.
Yeah, one of the things I would suggest, because I think that probably half the audience here knows exactly what the overlay and underlay mean, and the other half doesn't, because I'm in the background talking to people. Christina, can you take the action to have somebody help us write up clearly in the documentation what it is, so that when we have these conversations, people actually know what we're talking about? And to be honest, I'm not even
So we do
completely
have,
understanding it.
yeah, we do have in the wiki section, there's a glossary that we're building out to describe. Let me present, do you mind if I present my screen real quick, Chris?
Yeah, you can.
Okay.
And if I could suggest or throw in a question that I hope such a document answers.
On Christmas Eve, we shipped out the first batch.
Christmas Eve.
Yeah, your news feed started playing.
But one question that I since I don't know the precise distinction between overlay and underlay, one question.
That we were seeing. The United States is.
Sorry. Does the underlay, so the Microsoft controller wants to use some SAI APIs for controlling these Dash capable products. Is the underlay an implementation detail as far as the controller is concerned, or is it something visible to the controller? Is one of the questions I would hope this document answers.
I think the underlay is controlled by the controller, because otherwise the controller cannot deal with high availability.
Actually, the underlay is controlled by pure like Sonic generic like BGP usually. The underlay is all around the BGP. The controller control only the overlay and the overlay to underlay mapping, but not the underlay routing. It's totally not aware like is traditional overlay SDN versus underlay distributed protocol like BGP and so on.
And for the high availability, when we sync the information between two appliances, suppose, even in that scenario, we don't need any information of the underlay from the controller side?
Just a minute, there is a difference between information of the underlay, meaning the overlay to underlay mapping, like the name of the tunnel, to the underlay routing and forwarding. So of course the controller is aware of the overlay to underlay mapping, like the tunnels.
Sure.
But the controller is totally unaware of how underlay routing should work, like which port should forward that, what happens if a port underlay is down, and so on.
At the end of the day, this is a question for the Microsoft people that are porting this bird or whatever it's called, that is the mapping from GNMI to SAI, because that is the controller.
Silvano, I'm representing kind of the community, not NVIDIA. So we are quite familiar with the Sonic and the way we, as a community, we are planning to work with Dash. And currently, this is the plan. Like PGP will manage the overlay, the underlay, sorry, and the controller will manage the logical overlay tables and the mapping.
Yeah, this is Yuhua from Microsoft. I think Matty is right. I think the way to think about it is that our underlay is controlled by Sonic, right? It's a NOS on the box. Right, so whether it's
we can barely hear you.
Oh, sorry, can I hear me?
It's very difficult to hear you.
Okay, sorry. I'll find a different one. Sorry. Hello, can you still hear me now better?
Not much.
We can hear you clearly, but you're just faint.
Yeah.
Like it's not a noise problem or anything. You're just like very low.
Maybe you're far away from your microphone, but we could hear you. Could be that he's switching from another computer, so he'll just be a minute. So in the chat, if everyone can see, I don't know if everyone's monitoring.
Oh, all right.
Underlay is controlled by Sonic on the NOS via SI.
Right.
So one question I would have, and it could use some diagrams, is that if this was an appliance, and let's say it's these smart NICs are sitting in, you know, a Sonic type switch, you're running Sonic on the Sonic switch. You're also running Sonic on the actual NICs itself. And so I hear people talking about Sonic, and I don't even know which one they're talking about.
And Gerard, I think that is a crucial question. You know, I think we need to decide if a NIC to be compliant, smart NIC or whatever you want to call it, to be compliant with this Dash API need to run Sonic.
Originally that was the decision, but there's no diagrams that actually show that, okay, Sonic on a smart NIC does not need all of the same containers as Sonic on a switch, because it actually doing a different, slightly, you know, a different function. There's no diagrams that we've written about that actually show what the split of responsibilities are, because let's say, for example, I'll just give you a good example. Let's say you have your northbound interface is running on the switch itself. Let's say it's one piece of code running on the switch. Then that translates down to SI, but those, you know, SI commands are going directly into the smart NICs, but still via their Sonic. There's no diagram of this showing that Sonic is running twice. Once on the switch, it's also running in the smart NICs, and what is the split of responsibilities and what are the interfaces?
I kind of started drawing that here, Gerald, where I put the Sonic Tor at the top and
Sonic
the
Tor
NIC
is
here.
crucial. We need all of the, we don't need high-level diagrams. We need the lower-level diagrams showing where this Bluebird type agent that we want to write sits. If it's sitting in the Tor, then we need to draw it and make people aware of what the API is between that Bluebird agent and the smart NICs. Or if we're running it in the smart NIC itself, then of course it's different.
Hey, so can you hear me better now?
Yeah,
much better.
Oh, much better. Okay. Yeah. So previous, I think the in our mental model, right? So SI is basically the SDK, right? Sorry, the data plane abstraction to the ASIC or to the smart NIC, right? Whether it's underlay or overlay, right? And for the underlay function, we already have all the translation, right, in the Awk agent, right? So that's a valuable part that handles that. And we already know how to deal with it. So we are trying not to replicate that, redo the underlay part.
Okay, but are we talking about Sonic on the smart NIC when you say those words? Are you talking about, there's two sets of
I think we're talking about, it doesn't matter where it is hosted, right? Whether it's hosted on smart NIC or whether it's hosted on the switch, right? Because somewhere you need to have the underlay logic of handling or whatever those things, the translation happen, right? So, okay, maybe on smart NIC it's called a dash OS or whatever that is, right? But you need that translation logic, right? So those has been built, right? And so,
you know, but does that translation logic, does it on every single smart NIC? Like, let's say there's 8 on a switch. Is it the translation done on every one of them, or is it done once on the switch and then passed down to the smart NICs? It's not clear.
So even if you so-called pass it down to the smart NIC, somewhere this thing needs to be translated yet again into the actual hardware APIs.
Let me ask you a question here. Suppose that I deploy this on a switch and I have 8 smart NIC.
Yeah.
Okay. And I need to write some software for this 8 smart NIC. Yeah. Then I deploy a smart NIC on the server without the switch.
Yeah.
Is the software that I deploy on the smart NIC on the server identical to the software that I deploy on the smart NIC on the switch?
Okay. if it can be identical, that will really help us a lot, right?
Yes, it would.
I don't know.
Because
Is it a goal? I'm trying to understand. I understand the high level that you can do the translation here and there and that you can move it. All that is fine. I have no issue with that. I'm trying to understand what we are really trying to implement here.
So Silvano, currently this is totally the direction we are going at. Like having a discrete boxes that can run with a switch or without a switch, totally separated. Like each one of them is a standalone box.
Yeah.
So I think that's the advantage of using Sonic, but the models, so it means though that you still have different models, because if it's on the switch and you're all running Sonic, including the SmartNICs, and you have multiple instances of Sonic now.
Yes.
Do you have one instance of the Bluebird talking to multiple instances of through multiple instances of the Bash OSs, or are you running this Bluebird on every SmartNIC? Like, it's not clear to me. I don't see. We need to draw these pictures. You could do it both ways. I don't know, but we don't even have a picture of what the intent is.
Yeah.
Well, I think running Bluebird on every SmartNIC plus Sonic may be very heavy.
It sounds like it. I mean,
I see. Okay. So, if we're trying to run the appliance as a single entity, let's say exposed to the overlay stack, right? That's possible, right? So that the overlay stack the controller do not need to deal with all 9 entities, right? So then it's a NOS job to handle the translation, right? Of there's an incoming and how do I allocate on each of the 8, right? But it doesn't mean that we have to kind of mix it up into a different set of translation layer. Right, so I think, Gerard, if you look at the POC we built in the past of this VPN gateway, right? That's exactly what happened, right? So the controller layer is a single API exposed. Then the Sonic layer understand there's a 2 ASIC, right? One is a switch ASIC. The other one is at that time a DPDK emulation. Right, so both are exposed in side layer. The AUC agent takes the job of translating from the SDN controller, right, and into the ASIC side and the DPDK side, right, and each one handle different functionality.
Yeah, but when Marion says, my assumption too. When Marion says, don't worry about the underlay. The underlay will run BGP, and that's fine. If I have 8 cards, do I have 8 instances of BGP?
Okay, no. So that depends on the actual deployment setup, right? Let's say if each of them are having a BGP peering, then each of them could have a BGP, sure. But if we're doing the BGP peering on the switch, then you do not need to do that, right?
Then you just have your neighbors, yeah.
Yeah, it depends on your setup, right?
It sounds like we're just creating more questions now. We should have a goal for what we're building.
So Lihua, the orchestration agent you're saying will remain the same on SmartNIC or switch, but the software containers can vary if needed.
Yes, that's what we are seeing. Yes, exactly. The AUC agent's job is to do the translation between the controller object model to the SI model, right? So it doesn't really matter of which part where are you running. That's our goal, right? So that's the most complicated piece of all this Sonic stuff, right? Or whatever, all in all our translation, right?
But this ARC agent, if I understand correctly, where is it in Marion picture?
In which picture? So in this picture?
No, in Marion description. In what NVIDIA has presented in this pull request, which I'm not against, don't take me wrong. I'm just trying to understand.
It sounds like it's not. It sounds like it's not in. It's in the switch software. Is what Liwa I think is saying.
But if there is no switch?
No, it's not on the. Each box is run full-blown Sonic. Full-blown Sonic in terms of SWSS, the infrastructure.
Sorry,
now,
but only
to run the protocol.
Bluebird, though.
Just a minute. Bluebird is part of the application, the protocol that you are running. Now, whether you are running BGP peering on each one of them, or you are running a Bluebird agent on each one of them, or LACP protocol or other protocol, it's up to the topology and the installation and the network admin to decide.
Yeah.
But the Sonic look the same. It always have Orc agent and UpDB and ASICDB and all the pieces that come with Sonic.
So you're basically saying that we are mandated to run the full-blown Sonic on all the SmartNIC.
Sonic infrastructure, not all the Sonic.
Sonic infrastructure on all the SmartNIC.
Right.
Gohan, is that correct?
Wait
a second.
I didn't understand that was the goal of this project.
Would you clearly distinguish Sonic from quote Sonic infrastructure? I mean that's way too vague to answer the question.
Yeah.
Okay, so I think the way we would differentiate, right, is that whether it contains the full container, every single container in the Sonic OS or not.
Yeah,
right?
it's just a list of containers that run on each. Can we take a stab at that and just draw like a switch with a list of containers that runs on a switch and a list of containers that runs on the SmartNIC? Because that's the only difference, right? Just a list of containers.
Speaking, have to have a switch. If I have Sonic on the SmartNIC and the SmartNIC is doing forwarding, it is a switch. Now, I likely am plugging that into a bigger network. Therefore, I have, TORs and AG switches and spine switches and core routers and all manner of other beasts in there. But you said
we are trying to get rid of them. We don't want to actually. Today, that's what we do. We actually have SmartNICs operating independent of the TORs that sit up top, and all we do is just add on layers of hardware where it wasn't needed. We want to actually integrate this into the switch.
Yeah. So Sonic versus Sonic infrastructure, full Sonic versus Sonic infrastructure. What is the definition of the separation between those? Which of the containers and which of the Sonic services are in the Sonic
versus the switch?
What do you remember? That would be cool to know.
Yeah, I think following up on make a goal to write it down. I mean, you guys are all going to argue you could do it anyway, but let's pick one way that we think we're going to do, because we already have a goal to have an integrated TOR-like switch with lots of SmartNICs on it. Let's pick that as our model, take a stab at drawing what is running where, and we can always say, oh, you can do it differently if you want, but we should have a model that people are talking to.
Yeah, we need to put a stake in the ground, have a starting point document that describes all this from the architectural level down, top down, and then we can always pick it apart, but we need something, right?
Yeah, and this was a stab at creating a template to move around the containers when I'm presenting to show what we're going to use for the NIC. But Liwa, if I could have someone from the Sonic team draw out what we're trying to do.
Okay.
Even with the pencil, we have lots of writers and artists and everything. Don't even have to worry about that. If somebody can draw it with a pencil, it doesn't matter. We will actually turn it into something that looks really nice.
Okay.
You don't need to go and ask somebody to do some pretty slide. We have actually professional writers on the team, and they can do all that for you.
That's okay. Yeah, I think we can draw something out, right, on the container model, that what is going to run on the NIC side and what is run on the switch side.
Yeah, Lihua, the main question, right, is, you said Arc agent will translate into, from the SI to lower level implementation, right?
No, Arc agent is going to translate from the high level API to the SI model.
Yeah, so the key question, right, before we take a stab and say that, you know, this is the starting point for whatever discussion so we can agree on, the question is, can it translate for one switching pipeline below, or can it translate for multiple switching pipelines below? Because I heard you allude to another project where you had one ARC agent do like, you know, translate to multiple pipelines. One was hardware, one was DPDK. Were there alternatives, or they were like in parallel?
Yeah,
That's
so
why, yeah.
Venkat, sorry. I think when I say DPDK, right, we use DPDK, but we also wrap the underside, right? So Work agent translates from the high-level APIs into SI model. It doesn't matter what is underlying, right? The underlying SI implementation was done by, let's say, one ASIC versus another, or a software ASIC, right? Which is not actually ASIC. All those are fine.
Yeah, if that's the case,
right?
then yeah, you need.
We use SI to hide the hardware
No,
difference.
I understand. So that means you are not talking about full SI on each NIC. The possibilities are whether you have full SI on each, you need SI on each NIC, and may not be Sonic itself. Maybe that's the discussion.
Yeah, exactly. Right. So I think supposedly the NIC, right? Let's say only it doesn't have some of the more complex switching function, right? Then it doesn't have the SI objects, right? So you only have the overlay objects, maybe, right? And the switch doesn't have the overlay object. It only have the normal switching objects, right? But
that's a drawing we need. That's a drawing we need, at least as a step, so people understand it.
So who volunteers to help draw that?
So I think the Christina, I think I work with Gohan and Matty, etc. We can try to draw something out, right? I think we have those kind of things.
And we could build off of this drawing that I'm presenting.
Yeah,
I mean, that's why I created it.
Yeah, don't worry about this drawing though. Draw something on a whiteboard. Just take a picture of it and send it to us. Don't take any time to make anything beautiful. Just draw on a whiteboard, take a picture, send it.
And then we'll transform it into this. Yeah. So,
and I think the important thing also is to describe it in good prose too, so that's
So Gohan's on hold. He's not hearing any of this, that he's getting signed up for this, Liwa.
No, I'll talk to him. It's okay. Don't worry.
Okay. Yeah. All right. And I'll email you guys. Yeah. Okay. So we have.
I don't know. I don't know about others, but for the benefit of those who probably don't know what Bluebird agent is, could somebody describe what it is and the relevance with this project? Sorry, I don't know about this.
So is that Silvano? Yeah. Hey.
No, that was Hanif.
This is Hanif.
Oh, Hanif. Hey, yeah. Okay. Yeah. Sorry. Hey, Hanif. So Bluebird is basically think of it's a gRPC API, right? The incoming data model is let's say VXLAN, right? And for the VNet objects, right? And then it basically receives that VNet object. Then Sonic's ARC agent takes those VNet objects, translate into the VXLAN on the data plane.
Are Bluebird and ARC agent synonym?
No, Bluebird is a kind of and the ARC agent are two different containers, right? Bluebird is a more gRPC receiver. Then it writes to the FTP, right? Then the ARC agent takes the object out of the FTP and translate into SciDB. Because once you have the VNet objects, right? What you need to do is that you see there's a VNet that people are asking you to set up with some parameters, right? And then you map it to, you need to join the VNet objects and the data plane of which link is active, which route is valid, right? And the interface information to see this is how I'm going to create the VXLAN, right? So now you translate it from the VNet objects into a concrete VXLAN object into the SciDB.
So are these, Liwa, are these VNet objects, these are both configuration and data plane objects, or no. What are these objects that are coming from I'm assuming these are from some SDN controller, right?
Yes, the VNet object is from SDN controller, right? So think of it that you are an Azure user, right? And you basically said, okay, I want a VNet from create from this data center, this server into the other side, right? And in the same VNet, with this bring you your own IP address, right? And with this, whatever those parameter, right? And your VNet subscription ID is this, right? So those kind of the information that we have.
Yeah. So one step back is on Orca agent is a brain that to orchestrate all different objects from application and then go to the DB, go to the site. Bluebird agent is to receive the content from the SDN controller and control the configuration and the setup for the overlay configurations.
And where does this Bluebird agent run? Sorry, I had the same question, so thanks for asking.
So the agent, I think, Reshma, the agent you can look at basically that's a Sonic REST API.
It's running on the Tor.
Yeah, it's running on the Tor today, right? That if you look at the Sonic REST API, I think it's actually published, right? That's an entrance point you can see.
Yeah.
But if I have a SmartNIC, does the Bluebird agent run on the SmartNIC?
Okay. Silvano, I think that depends on how are we actually going to deploy the form factor, right? So if the SmartNIC is completely on its own, right? So think of the it's in the server and it's completely on its own. There's no switch involved at all. Then it has to be the Bluebird agent container has to run on the SmartNIC itself. If we're doing this, what Gerard talked about, we're doing a smart switch, right? There is a full NOS on the switch already. And the switch are receiving the VNet objects or Bluebird already. Then there's no need to run a Bluebird agent on the SmartNIC yet again, right? So in that kind of deployment, you will be a direct Orca agent setup.
Yeah, but my recommendation will be, if you want this project to be successful, that you define an initial scope of this project in which we support one configuration, we support it well, and we don't support multiple different configuration, because
I think we're starting off with the switch configuration. I don't want to start off with the host as the initial goal, because that's not what we're going to deploy, and there's other reasons for that. But from the initial steps, I think we should assume we will have smart TORs that will have switches and at least 8 SmartNICs on them within a year. And we want to intercept that market.
So essentially the serious appliance, the one that we have the pipeline for, right?
Serious appliance, no, because serious appliance is slightly different and there is no switch on it. We had to put the TORs in the rack separate. So it's running Sonic separately from it. We don't want that model moving forward. It's a waste of hardware, and it costs a lot more to do it that way. So now we just want to combine the function. The Sonic switch with a bunch of SmartNICs that are actually hardware-wise integrated into that switch is the model that we want to deploy for 2023. In the meantime, we can deploy Sirius, but we're heading towards a more integrated model.
Then I highly recommend that we do a drawing of the smart switch first, and we agree on the drawing of a smart switch.
Yeah, in the interest of time, can we agree on, or at least can we write down what are the goals for what Lihua gives, so that we don't go on another iteration? I just typed something in the chat to see if that makes sense to anyone, or can anyone add or done that? I'm trying to see where all Psi and Sonic instances will run, because you have one switch and then 4 NIC cards. Is NIC also a switch? Is NIC abstraction a Psi, or is it a Sonic abstraction? So I think if we know at that high level other details in terms of Orca agent and the communication and APIs, we can figure out.
If the model is a smart switch, so it's an intelligent port switch, that model has been around in the industry off and on for 25 years or so. And if that's the model, then the DPU can be configured as a intelligent port rather than a full-blown switch. And in fact, you wouldn't want to configure that as a full-blown switch, because really that then looks like a network in a box, which has never been particularly successful outside of big routers, right? No one wants to buy those outside of big routers. And you can understand how that model would work, but that's not a general purpose API for a SmartNIC DPU IPU type box. That's a smart switch API that's much more restricted. So I'm very curious as to which direction Dash and the Bluebird agent really wants to go here, because that's the first I've heard of this, and I completely understand it. I could draw you all the diagrams, this afternoon, but it's kind of an interesting thing compared to everything I had heard previously over the last 4 months.
Well, I think the answer is all of it, though, where we want to iterate through the appliance, the switch, and the NIC.
Okay.
But the initial, guys, looks like the initial goal that Gerald is talking about is what we generally describe as bump in the wire, right?
Mm.
So
yeah, the near-term goal.
Yeah, intelligent smart switch, where the offload functions are then a bump in the wire. Exactly.
It's good to have one initial goal, and other things, as long as we don't preclude them from happening later, that may be enough. So it's good to start with one. Dan say that I have a server model, I have a switch model, I have a distributed switch model. That might make it complicated.
Okay, so we're at time, and so probably for the next meeting, hopefully we'll have the drawing of where Sonic actually runs, whether it's the, and start again with the first scenario. Anything else, guys, before we drop off? Marianne, did you need some help with writing any of the pieces you were working on?
Yeah. So I will point to that from the pull request.
Great.
The list.
So is it the agreement that we are going to accept that pull request?
Well, I think it depends on the comments in the pull request.
Yeah, it wasn't reviewed yet, I guess.
How does it work? Usually is people present their pull request, and then the community add comments, and we address the comments, and the people who make comment needs to close it and before the merge.
Yep.
I think the pad didn't upstream the code to yet.
What's that?
I mean, the Dash program doesn't upstream the code to the Sonic community yet. You just pull the code. And Dash is still private or limited.
I'm sorry, you're breaking up a little bit, Enzo. I'll try and catch up with you afterwards. Gerald, anything else?
No.
Okay. All right. Well, I'll see you next week.
Thank you so much.
Christina.
Okay.
Thank you.
Thank you.
Okay,
Bye-bye.
thanks everyone. Bye.
Thanks, guys. Bye-bye.